actual implementation. So in actual implementation, you just recall that the execution starts with the first component called program counter. Program counter, which used to hold the address of next instruction, which will be ready for execution. So program counter holds the address of next instruction. So up on the address issued to the instruction memory, the instruction will be fetched from this memory. The next step, correct? In actual implementation. So here the data path is connecting program counter and instruction memory component. So is this make sense? This is the data path, which is connecting program counter and the instruction memory. So you just recall that every instruction is having the logical address. So the program counter holds the address of the next instruction, which is going to be executed. That is 0, right? So then what is happening? This instruction is in the instruction memory. So program counter connected to this instruction memory. Okay. Does that make sense? So the next step is the instruction is fetching from this instruction memory based on this address. Program counter issues 0. So the instruction is fetching from the memory. So let us assume this instruction is a arithmetic instruction. Okay. So that arithmetic instruction is, if the address is 1, the arithmetic instruction add R1, R2, R3. So this instruction will be fetched. This instruction is fetched. Next stage is instruction decode stage. So in the instruction decode stage, what it do, it decodes this instruction. It finds what are the source operands and what are the destination operand. So what are the source operands here? Source operand is R1 and R2. Source operands are R2 and R3, and destination operand is R1. So the instruction decode stage. So 3 registers are there, so the data path is connected to 3 registers. Does that make sense? Okay. The next stage is execution stage. So which component is there in the execution stage means ALU, which performs the actual operation. So this arithmetic and logic unit takes 2 inputs and generates 1 output. So what are 2 inputs? R2 and R3. So the data from R2 register and R3 register is reading from this register file, right? Sorry. So then ALU performs the add operation, and the result is writing back into the register file only. The data is writing back into the register. Which register? R1 register. So the data path, the output data path is connecting back to the register file as an input. Right? So practically on CPU simulator, if you look at with this simple example, so program counter is, I hope it makes sense right now. Jonas, Hele, so far good. Okay, I have to go on this later. Okay. Ikar, Kashmi. Yes, please, Kashmi. Yes, this is inside the CPU, correct? Yes, Kasper. We are designing this only the inside the CPU, not outside the CPU. You're right. I appreciate. Yeah. So let us assume, okay, the program counter PC is having the address of next instruction in this example, let us say 2. So then this data path carries 2 here. So in the instruction memory, go to the second byte and fetch this instruction, load instruction. So the instruction will be fetched. So what is there in this load instruction? It is going to compute, okay, loading the value from this memory location. So what is there? R2 is holding the base address and immediate value means the offset. So the ALU first performs this. The ALU performs this operation. So what is that? It computes the effective address. So that effective address is base address plus the immediate value. Immediate value is not from register. It is a direct value, right? So this immediate value is the second input to the ALU to compute the effective address. Isn't it? That immediate value. So the ALU output is connected to the memory. Which memory? Data memory. So it computes the effective address and the output line data path is connected to the data memory because it must copy the data from this location into the register. So this effective address gives the base address plus immediate value, that gives the effective address. And from that address, the data is retrieving. That means reading the data. Okay. So the data port of the output port of data memory is going to connect back to the register because the value will be right into this register. Okay, so the data is reading from data memory and writing into the register file. For this, so then the second instruction is set to be executed. Then program counter, which holds the address 2 now, so that will be added with another byte. So that generates the address of the next instruction. So let us assume the next instruction is the store instruction. And the address of this instruction is suppose 3, which is given by program counter. So store instruction will be fetched from this instruction memory. In the instruction decode, it decodes that the operation code is store and the source 1 operand is the effective address, source 2 operand is the register file. So in this case, what happens when the instruction is decoded? The ALU, it computes the effective address, right? R2 plus immediate value, effective address of the data memory. So once that address is identified, then the value which is there in R1 register will write into this memory. So that data port will be activated and the immediate value, the value which is reading from, if you observe here, suppose the value in R1 register, that will be read and write into this data memory for store instruction. Okay, does that make sense or shall I repeat? Okay, program counter holds the address of next instruction, that is branch instruction. So in the instruction decode stage, it decodes, it is a branch instruction, and this one is the target value. So another ALU is required. We call that as adder 2. That takes the current instruction address plus the immediate value as an input, and the output is branch target address, and that branch target address updated in the program counter for execution of the next instruction.